Hello everyone, I heartily welcome you. I, Gaurang Chapaneri, founder of Mechanical Guru 2020 YouTube channel. In this video, I have covered overview of assignment problem or model. In that, I will cover categories of assignment model and methods to solve the assignment problem and the most important steps of Hungarian method. If you like my video, then please subscribe it and press the bell icon to get latest notification and don't forget to press the like button. Now we will go to the assignment model. In today's video we discuss the assignment problem. So first we understand the assignment models. See, basically the assignment model is a minimization model of LPP. The assignment problem is a special case of the transportation problem. There are some specific value for the decision variable and the constraint. In that, there are a few groups or tasks and some of the rules. The rules basically each individual is assigned to one task only, and the second rules each task is performed by one individual. Suppose there are n tasks which are required to perform using m resources per person. The effectiveness of each facility for each job is also known. So the problem is to assign each facility to one and only one job such that the optimization is important or effectiveness. Here the Cij is a cost associated with assigning ith resource to j activity, and there are some cases like m is equal to n, m is not equal to n, Cij and Pij. So this is the basic terminology, or we can say basic introduction of assignment problem. Let's see categories of assignment problem. So basically four categories of assignment problem. So the first, balance minimization, means m is equal to n with Cij. So in that, number of row is equal to number of column. Second, unbalanced minimization, that is m is not equal to n with Cij. In that, number of row is not equal to number of column. Third case, balance maximization, m is equal to n with Pij. So in that, the problem is maximization, but number of row is equal to number of column. In the last case, unbalanced maximization, m is not equal to n with Pij. So in that, again, the problem is maximization, but number of row is not equal to number of column. So there are four categories of the assignment problem. Okay, we will discuss one by one in each video. Now, next part, methods to solve the assignment problem. Okay, the first method is integer programming method. Second, enumeration method. Third, transportation method. And the last, Hungarian method or reduced matrix or floods technique. Okay, so the assignment problem we can solve by the four different methods: integer programming, enumeration, transportation and Hungarian method. So each method we will discuss one by one in the next slide. So first we understand integer programming method. So in integer programming method, basically all xij is equal to 0 or 1, means 0 or 1 integer programming. In that, where I is represent 1, 2, 3 dot dot n and j is represent 1, 2, 3 dot 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 n. For n by n problem, the variables is equal to n into n and the constraint is equal to n plus n, that is 2n. Let's see for 5 by 5 problem. So as per this table, variables 25 and constraint is 10. Similarly, if we go 6 by 6 problem or 6 by 6 matrix, then the variables is 36 and constraint is 12. If we similarly go in a 7 by 7 problem, then variable is 49 and constraint is 14. So this method is difficult to solve manually. Okay, let's see next method. Enumeration method. Same thing in enumeration method. Suppose the matrix is 3 by 3. So there will be a possible solution is 6. Similarly, if you consider 4 by 4 problem or 4 by 4 matrix, then the possible solution is 24. Similarly, 5 by 5, 120. If you go in a 6 by 6 matrix, then the possible solution is 720. So again, it's difficult to find out the feasible solution in enumeration method. Now we will go to the third method, that is transportation method. So as per the transportation, m plus n minus 1. In assignment, n plus n minus 1, that is 2n minus 1. Due to special structure of this problem, none of the solution can be more than n assignment. Because assignment problem is inherently degenerative, or we can say in order to remove the degeneracy, the n minus 1 is a dummy allocation are required to be added. So this method becomes cumbersome of insufficient. So it's also difficult to solve the problem. Now we go to the next method, that is Hungarian method. Is also called as the reduced matrix or Flood's technique. So the Hungarian method is a quite efficient and the time saving technique. So in that, just we have to follow some of the important steps, so we can easily find out the solution in a less time compared to other method. So the step number 1, prepare a square matrix. Means the number of rows is equal to number of columns. If it is not, then add the dummy row or dummy columns. Next, step number 2, that is row deduction. So in the row deduction, subtract the smallest element of each row from all the elements of the row. So there will be at least 1 0 in each row. Step number 3, column deduction. Same, subtract the smallest element of each column from all the elements of the column. So there will be at least 1 0 in each column. Next step, assign 0 and mark 0. In one more thing, in step number 2 and step number 3 completed, in the matrix, in each row, in each column, at least 1 0 is there. Next step number 4, that is assign 0 or mark 0. So in that, we have to follow the different steps. So the first step, from top to the bottom, identify the rows having only 1 0 and mark those 0 by square and cross all other zeros in the same column since it will not be considered for making any more assignment in that column. The next, from the left to right, identify the columns having only one zero and mark those zero by square and cross all other zeros in the same column since it will not be considered for making any more assignment in that column. Then next, if a row or columns have two or more unmarked zero and one cannot be selected by inspection, then select the zero cells arbitrarily for the assignment. Repeat above step until all zero in that cost matrix are marked either by square or cross. Okay, so after the completion of step number 4, that is assign 0 and mark 0, we will reach two possible. The first possibility is there is a one assignment in each row and each column. So in this case, we will get the optimal solution, or we will get the optimal assignment can be made. And the second possibility, if there is some row or columns without assignment, in this case the optimal assignment cannot be made in that solution. So in that we have to follow the next step, that is adopt tick mark procedure. So again in that we have to follow the some point. So the first point, tick mark row or rows where there is a no assigned zero. Next, tick mark columns with respect to cross zeros in a marked row and rows. After that, tick mark rows with respect to assigned zero in a marked column and columns. Okay, and go to the step number 2 and repeat the procedure until no zero is available for tick marking. Then next, draw a line through an unmarked row and mark column. Okay, so here the step number 5 is completed. Now we will go to the step number 6. That is modify matrix, is also called as the revise the reduced cost matrix. So in that what we have to do is simple, find out the minimum number out of uncrossed number. Then deduct this number from all uncrossed number one by one and add this value to that cell which is at intersection of both the line and keep other elements as it is. Okay, so here the step number 6 is completed. After that again go to the step number 4, 5 and 6 until we get the optimal solution. Yeah, so this is the Hungarian steps. Thank you everyone for watching my video. For any query or suggestion, you can contact me. This is my mobile number and this is my mail ID. Once again, thank you everyone.